A stepper motor generates defined angular rotations. For this purpose, the stator, hence the fixed part of the motor, consists of several electrically and thus also magnetically isolated stator parts. In our example, we have 3 such parts. The rotor, hence the rotating part of the motor, with the motor shaft, consists of permanent magnets that take effect across the entire length of the motor. If a part of the stator is magnetized through voltage application, the rotor rotates per the magnetic effect until magnetic stator and rotor poles with different names point to each other. Thus, this position of the rotor is achieved when the first part of the stator is energized and thus magnetized. As described before, the stator consists of 3 parts. These 3 parts are fully identical. Pole width W of the magnetic field is also identical for all 3 parts. However, seen in the direction of the axis, the 3 stator parts are offset against each other. Compared to stator part 1, stator part 2 is offset and mounted by 2/3 of pole width W, and stator part 3 has an offset of the same amount, 2/3 of pole width W, compared to stator part 2. Thus, stator part 3 is also offset by 2/3 of pole width W from the following pole of stator part 1. If stator part 2 is now energized and thus magnetized, the rotor turns clockwise by exactly 2/3 of pole width W. This rotates the motor. This procedure is continued by energizing stator part 3 and the rotor turns by the same amount. This ensures a continuous rotation of the stepper motor.